Good morning, Phoenix class. Welcome to our maths lesson for today. I can investigate the angles in a polygon. So our first question today are what are the angles in the quadrilateral Lexi has created? Now, if we have a look at that first picture, Lexi has two triangles and she's going to put those two triangles together so she makes a four-sided irregular quadrilateral. So let's have a look at the angles. We've got the 80 degrees angle. Well, that's still going to remain the same. Then we've got 75 and 75. So we're going to add those together to find that angle. The 75 in the lower right-hand corner, that one's going to be the same. And then we've got at the left-hand side, we've got 25 degrees and 15 degrees. So we are going to add those together. So here we are. 25 plus 15 is 40. So that angle in our quadrilateral is going to be 40 degrees. And then 90 degrees plus 75 degrees, that's 165 degrees. With our 80 and our other 75, if we add all of those up together, it comes to 360. Well, that's the same as we found out in the other shapes we were looking at yesterday. But this quadrilateral isn't a parallelogram or a rhombus or a trapezium, is it? It's a very odd-shaped quadrilateral. It's completely irregular. So that's telling us that interior angles of a quadrilateral add up to 360. I wonder if that's any irregular quadrilateral. Lexi is wondering exactly the same thing because all of her angles add up to 360. I wonder what shapes we can cut our quadrilateral in. Have a look. We can cut a four-sided shape into triangles. We just want to cut them into the smallest number of triangles we can. So if you have a look here, we've got a rectangle and a parallelogram and a rhombus and a trapezium, and we can cut all of those into two triangles. Can you remember how many degrees there are for the internal angles of a triangle? You're right, it's 180. So 180 plus 180, or 180 times 2, is 360. So if we can cut our quadrilateral into the smallest number of triangles we can work out the total amount the angles add up to. Have a go at this one. So in A, I've given you 4 of the angles. What do the angles of a quadrilateral add up to? Use your generalization to help you. So you need to add all of those together and take them away from 360. That's the same in B as well. And in C, we've got another irregular quadrilateral. But remember, although we have 2 angles of 30, we know how much that one with the square is, don't we? Because we only ever put a square in to show an interior angle if that angle is exactly 90 degrees. So now you know all 3. Can you work out what the missing one is? Question 2. Now, Max has made a kite and a rhombus on his geoboard. For both shapes, how many angles do you have to measure before you can calculate the rest of the angles? Now, I don't want you to do any measuring. What I want to know is just how many angles you would need to make. So the first thing you're going to be looking for is thinking about the properties of those two shapes. If we look at A and the kite first of all, can you spot any angles that are the same? Can you find a pair of equal angles? There's one pair in there. So if we knew what the pair was, one of the pair, then we would know what the other one was. But would that be enough to help find the others? It wouldn't, would we? Because they're not equal. So how many angles would we need to know? And how many could we work out? In B, we've got a rhombus. So what are our properties of a rhombus? We've got two pairs of parallel lines and two pairs of equal angles. So this time, how many angles would we need to know to be able to work out how many each of them is? Right, onto our practice book already. Question 1, more of the same, finding the missing angle in each shape. Please remember, all angles in a quadrilateral add up to 360 degrees. As long as you remember that, you'll be able to work out the rest. In number 2, in each shape, one angle has been labelled incorrectly. Identify the angle and calculate its correct value. So you can do this without having to measure. What I want you to think about is, first of all, are the angles acute or should they be obtuse? Are they more than 90 degrees or less than 90 degrees? Always thinking, what does a 90-degree angle look like? And if you're stuck with that, the corner of a piece of paper is always 90 degrees. So all you need to do is think of a corner of a piece of paper and that will tell you. Sorry. Number 3, draw lines to split each shape into triangles. Write the angle total for each shape. Now, A is a quadrilateral. It's got 4 sides. So we're going to split that into 2 triangles. But look at B. B has 5 sides. So we can't just split that into 2 triangles. We're going to have to split it into 3. Remember, angles in a triangle add up to 180 degrees. So if you've got 3 triangles, what are they all going to add up to? Then have a look at C. That's got 6 sides. So what is the fewest number of triangles you can split that shape into? Then add up all your 180 degrees. In question 4, Emma says, I split this shape into 4 triangles. There are 180 degrees in each triangle. 180 times 4 is 720. So this quadrilateral must have internal angles that add up to 720. Now, Emma isn't right. She's made a mistake. Can you explain what it is? Think about what I've just said for the question above. Calculate the interior angles on number 5 of a regular decagon. So count how many sides it's got. And remember, you want to split it into the smallest number of triangles you can. That will help you. After that, you've got challenges if you would like to have a go at those. You've got your missing angles if you would like to have more practice with those of various different quadrilaterals there as well. The answers are at the end. Please remember to mark it and then send me pictures. Can't wait to see what you've been up to. Remember, you can repeat the video anytime to give you a hand. Have fun!